The world around us is made from familiar stuff: wood, steel, glass, and plastic. But deep inside laboratories, scientists have created materials that seem to rewrite the rules of physics itself. These are substances that swallow light, flow without friction, or heal their own cracks. They challenge our understanding of what matter can be. Today, we're exploring 10 of the weirdest materials ever discovered, marvels of science that seem to belong more to science fiction than to the real world. Let's begin with number 10. Number 10, superfluid helium. At room temperature, helium is a familiar gas used in balloons. But when cooled near absolute zero, it becomes something extraordinary. A liquid that flows without friction. Known as superfluid helium, this strange state of matter behaves unlike any other fluid on Earth. It can creep up walls, leak through microscopic cracks, and even flow endlessly in a loop without losing energy. The transformation occurs at extremely low temperatures, around 2.1 Kelvin for helium-4. At this point, helium atoms lose their individual identities and merge into a single quantum state. In effect, the liquid behaves as one giant atom. Its viscosity drops to zero, allowing it to flow indefinitely. Even heat moves differently here. Waves ripple through the fluid instead of diffusing normally, creating bizarre effects like fountains of liquid climbing out of containers. Superfluidity was discovered in the 1930s, shocking physicists. It provided one of the first glimpses into quantum mechanics at macroscopic scales, showing how quantum rules can govern something visible to the naked eye. The discovery earned Piotr Kapitsa a Nobel Prize in 1978 and remains one of physics's most beautiful examples of nature-defying common sense. Though practical uses are limited, maintaining such low temperatures is difficult. Superfluid helium plays a vital role in scientific research. It's used in cryogenics, particle accelerators, and space instruments. It remains a haunting reminder that the deeper we push matter, the stranger it becomes. Number 9. Graphene. Graphene is often called a wonder material. A single layer of carbon atoms arranged in a perfect honeycomb pattern. It's only one atom thick, yet stronger than steel, lighter than aluminum, and more conductive than copper. Discovered in 2004 by scientists at the University of Manchester using nothing more than Scotch tape and graphite, it won them the Nobel Prize in physics. At a molecular level, graphene's strength comes from its two-dimensional lattice of carbon-carbon bonds, the same bonds that make diamond hard. But unlike diamond, the atoms lie flat, creating a sheet so thin it's nearly invisible. A single gram could cover a football field, and yet it can support massive weight without tearing. Its electrical properties are just as stunning. Electrons move through graphene at near light speed, making it ideal for transistors, batteries, and flexible displays. It could transform energy storage, foldable electronics, and even water filtration, thanks to its ability to block every molecule except hydrogen. The only barrier is production cost. Growing defect-free graphene sheets at large scales remains a challenge, but progress continues. Once mass manufacturing catches up, graphene could reshape entire industries, all from a material just one atom thick. Number 8. Starlite. In the late 1980s, a British hairdresser named Maurice Ward claimed to have created a material that could withstand temperatures higher than the surface of the sun. He called it Starlite. In TV demonstrations, Ward coated an egg in Starlite and blasted it with a blowtorch for minutes. When he cracked it open, the egg inside was still raw. Viewers and scientists were stunned. Starlite seemed to defy thermodynamics. It resisted open flames, laser heat, even nuclear flash tests, without burning or transferring heat. The material darkened slightly but never melted. Ward said it could endure 10,000 degrees Celsius, far beyond known polymers or ceramics. Yet he refused to reveal its formula, fearing theft or misuse. Experts suspected it was a blend of polymers, ceramics, and organic materials, but no one ever confirmed it. NASA, Boeing, and military agencies expressed interest, but without access to the formula, collaboration stalled. Ward died in 2011, taking the secret with him. To this day, Starlite remains a scientific legend, perhaps real, perhaps exaggerated. It represents a fascinating what if, a material that might have changed aerospace and safety engineering forever, if only its inventor had shared it. Number 7. Gallium. Gallium looks like ordinary silver metal, but hold it in your hand and something shocking happens. It melts. With a melting point just below 30 degrees Celsius, 86 degrees Fahrenheit, the warmth of human skin is enough to turn solid gallium into a shimmering liquid. Watching it melt feels surreal and as if the laws of metal have been broken. This strange element was discovered in 1875, confirming a missing entry on Dmitry Mendeleev's periodic table. It's liquid over an enormous temperature range, from just above room temperature to over 2000 degrees Celsius, without evaporating. Unlike mercury, gallium isn't toxic, making it safe to handle, even though it can damage other metals like aluminum by seeping between their crystal layers. Gallium's real power lies in its compounds. Gallium arsenide is a cornerstone of modern technology, used in LEDs, laser diodes, and solar panels. Its ability to conduct electricity and light efficiently makes it vital in smartphones, satellites, and high-speed communications. Few elements are as visually deceptive. One moment it's a solid metal, the next a reflective pool of liquid metal in your palm. Gallium challenges what we think metal is supposed to be: rigid, cold, and unyielding, and turns it into something alive. Number 6. Transparent aluminum. Alon. For decades, transparent aluminum sounded like pure science fiction, but in the 1980s, researchers at Raytheon turned that idea into reality with a ceramic material called aluminum oxynitride, or ALON. It's clear like glass, yet tough enough to stop bullets. Alon is made from a crystalline mix of aluminum, oxygen, and nitrogen. When processed at high temperatures and polished, it becomes optically transparent but extremely hard. It can withstand impacts that would shatter glass or crack acrylic. Its hardness ranks just below sapphire, making it ideal for armored windows and infrared lenses. Unlike conventional bulletproof glass, which is thick and layered, Alon offers the same protection at a fraction of the weight. It also transmits light from ultraviolet to infrared, making it valuable for military sensors, spacecraft, and high-performance cameras. It's expensive to produce, but as costs fall, Alon may soon appear in commercial tech. Think scratch-proof smartphone screens or aircraft canopies. A material once imagined in Star Trek is now real, proving that sometimes science fiction simply predicts the future. Number 5. Terfenol-D. Terfenol-D is a metal that moves when exposed to magnetism. Made of terbium, dysprosium, and iron, it expands and contracts in response to magnetic fields, a phenomenon called magnetostriction. The change in size is tiny, only micrometers, but strong enough to create motion you can harness. Developed in US naval laboratories in the 1970s, Terfenol-D was designed for sonar, to turn electrical signals into underwater sound waves and back again. It's since been used in precision actuators, sensors, and vibration control systems. Its movement is so reliable that it's used in high-accuracy machines where even a fraction of a millimeter matters. Unlike most materials that need motors or pressure to shift shape, Terfenol-D responds instantly to magnetism, making it efficient, durable, and nearly silent. It's also reversible. Remove the field and the metal springs back to its original form. It's expensive, relying on rare earth metals, but the behavior itself seems almost alien, a solid piece of metal that twitches under invisible magnetic force, a reminder that the line between mechanical and magnetic can sometimes blur. Number 4. Metallic glass foam. Imagine a metal that's as strong as steel, yet light as plastic. That's metallic glass foam, a hybrid of two impossible sounding ideas. It's made by blowing gas through molten metallic glass, forming bubbles that solidify into a porous, sponge-like structure. The result is surreal, a chunk of metal filled with microscopic cavities that make it incredibly light, but still strong enough to absorb massive impacts. Press down on it and it compresses gently before springing back. Almost like memory foam, except it's metal. Because metallic glass already has an amorphous atomic structure, the foam retains the same resilience, toughness, and corrosion resistance. Engineers see huge potential in crash-resistant car frames, lightweight armor, and medical implants where strength and weight both matter. It's still expensive and experimental, but prototypes show extraordinary energy absorption and shock resistance. Metallic glass foam defies intuition, proof that even metal can be light, flexible, and protective all at once. Number 3. Teflon, PTFE. Teflon began as a laboratory accident in 1938. Chemist Roy Plunkett was testing refrigerants when one gas cylinder mysteriously jammed. Cutting it open, he found a waxy white solid that refused to react with anything. That solid was PTFE. Later branded as Teflon, chemically it's made of carbon atoms wrapped in fluorine, one of the strongest bonds in nature. This shield makes it incredibly inert. Acids, bases, and solvents can't touch it. it. Its surface is so smooth that almost nothing sticks, giving it the lowest friction coefficient of any solid. Today it's everywhere, from non-stick cookware and cable insulation to aerospace parts and medical devices. It withstands extreme heat, resists corrosion, and doesn't conduct electricity. For decades, it's been a cornerstone of modern industry. What makes Teflon weird isn't just its slipperiness. It's how something born from an accident ended up shaping everything from frying pans to spacesuits. It's proof that sometimes the greatest discoveries happen by mistake. Number 2. Lutetium aluminum garnet, LuAG crystals. Hidden deep within advanced laboratories are clear crystals that glow when struck by radiation. They're called lutetium aluminum garnet, or LuAG, and they're among the densest, most stable transparent materials on Earth. Formed from lutetium and aluminum oxides in a garnet structure, LuAG combines optical clarity with high density, something rarely found together. This allows it to stop high-energy particles and emit visible light, making it perfect for medical scanners and laser systems. Used in PET imaging, LuAG scintillators convert gamma rays into light, so detectors can map the inside of the human body in stunning detail. It's radiation hard, thermally stable, and maintains transparency under intense energy, traits few materials share. It's expensive, rare, and almost unknown outside of science circles. But without it, many medical and nuclear technologies simply wouldn't exist. A heavy crystal that glows from invisible energy, LuAG feels less like a material and more like something out of science fiction. Number 1. Amorphous ice. We all know what ice looks like: clear, crystalline, geometric. But amorphous ice breaks every rule. Instead of forming neat patterns, its molecules freeze in chaos, creating a solid more like glass than crystal. It's still water, just rearranged into something alien. On Earth, you can't make it naturally. You need to freeze water so fast, or under such pressure that the molecules can't align. Scientists create it in labs or observe it on comets and icy moons, where space's deep cold freezes vapor instantly into amorphous form. This strange ice may hold clues to one of science's biggest mysteries: why water behaves so differently from other liquids. Some physicists believe amorphous ice hints that water has two liquid states, separated by a hidden phase boundary deep below freezing. In the vastness of space, amorphous ice is everywhere, covering dust grains, feeding comets, shaping alien worlds. It reminds us that even the most ordinary substance on Earth can behave in ways we've barely begun to understand. From blacker than black coatings to metals that move, heal, or melt in your hand, these materials reveal just how strange the world can be when you look close enough. They blur the boundary between science and magic, showing us that nature and human ingenuity still hold plenty of surprises.